Dear students, in this video I am going to discuss the last method of numerical solution of initial value problem, which is Milli predictor corrector method. So this is a multi-step method. You can see the diagram of this method. Fine. So this is a Milli predictor corrector method in which first we predict the value and then we will correct the value number of times, just like in Euler's modified method. First we predict the value with the help of Euler's method and then the value is corrected with the help of Euler's modified method scheme. Similarly here in Milli predictor corrector method we are having two formulae. One formula is for the prediction and another formula is for the correction. Fine. So let's see. So first this is the differential equation with the help of, this is the initial value problem. So this is equation number 1. Fine. So now here in this method, first we will discuss about the prediction. For prediction, this we will take 4 past points. That means we want to predict the value yn plus 1 here, yn plus 1. For the prediction of yn plus 1, we need the value of yn, we need yn minus 1, we will need yn minus 2 and y of n minus 3. So once we are having these values, then we can predict the value of yn plus 1. Fine. So now to do this, first we will integrate equation number 1 from limit xn minus 3 to xn plus 1. We will integrate the fine. So integrating this equation with limit xn minus 1 to xn plus 1 is equals to integral xn minus 3 to xn plus 1 f of x dx. So what we will get after simplification, this we get yn plus 1 is equals to, here we get minus 1 yn minus 1 3 which will come in the right hand part. So yn plus 1 is equal to yn minus 3 plus integral xn minus 3 to xn plus 1 f of xy dx. So this is equation number 2. Now we will find out this f of xy with the help of interpolation. Interpolation means Newton's Gregory forward difference. Newton's Gregory forward difference. So since we have these 4 data points, our target is to find out this. So these are already known to you, yn minus 3, yn minus 2, yn minus 1 and yn. So these are already known to you. That's why we have x is xn minus 3, xn minus 2, xn minus 1, xn. These values are already known to you. So find out the differences. So first difference column, second difference column and third difference column. Fine. So now with the help of now Newton's Gregory forward formula, fxy, which is approximately a cubic polynomial because 4 data points are known to you. So you can easily fit a polynomial of degree 3. So this is a 3-degree polynomial which is nothing but f of n minus 3 plus u into this delta f of n minus 3 plus u into u minus y factorial 2 into this second order difference n minus 3 plus u into u minus 1 into u minus 2 divided by factorial 3 and third order difference. Fine. So where u is given by x minus the origin point. Origin point is obviously here this x n minus 3. This is the origin point. So x minus xn minus 3 divided by h. क्योंकि यहाँ वही पॉइंट आता है जो स्टार्टिंग पॉइंट होता है. स्टार्टिंग पॉइंट इज xn minus 3. So x minus xn minus 3 divided by h. The distance. This is the distance between each point is h. So from here dx is h du. So now substitute these values in equation number 2. So yn plus 1 is equals to y of n minus 3 plus h, because here is dx but dx is h du. So therefore h is here. Now in place of f we are having this polynomial, integrating this interpolating polynomial in terms of u. So this is polynomial du, this du from here, and then now the limit in terms of u. Here the limit is in terms of x, here the limits in terms of u. So when x is xn minus 3, so put x equal to xn minus 3 here. So what you will get? You will get 0. Put x equal to last value xn. When you substitute xn plus 1, then xn plus 1 is nothing but here the xn plus 1 minus xn minus 3. How many difference? H, 2h, 3h and 4h. So 4h divided by h, this will give you 4. So this is the procedure. Now just integrate with respect to u and then substitute the values after simplification. So this is the calculation, just you can see, fine, and validate yourself. And then finally after simplification, substituting the values of all the differences, substituting all the values of these differences, so what we will get, we will get this formula: yn plus 1 is equals to y of n minus 3 plus 4h by 3 to f of n minus 2 minus f of n minus 1 plus twice of f of n. So this is an explicit method. Explicit method means in the right hand side you can see that all the indices are used which are basically the related with the previous data. For example, yn minus 3, n minus 2, n minus 1 and then we are predicting n plus 1. Fine. So this type of form is known as, whenever the right hand side is known to you and you are evaluating the left hand side, then that type of form is known as explicit method. जब भी हमें लेफ्ट राइट हैंड साइड सब कुछ पता हो और हम लेफ्ट की वैल्यू निकाल रहे हो, तो दैट इज नोन एज एक्सप्लिसिट मेथड. फाइन. So this is the prediction formula. This is the prediction method. Now let us talk about the correction method. So now again taking this equation number 1, again we are taking this, integrate again equation number 1. Now we are taking the limit from xn minus 1 to xn plus 1. That means we are taking only this data point from here to here. We are not considering this range, complete range from xn minus 1 to xn plus 1 only. That means only 2 data points. Fine. So here this is xn minus 1 to xn plus 1. So this is equation number 1. After taking integral we are getting this, and here this is the table, difference table. So now find out this. Now find out this f of x again with the help of Newton's Gregory difference formula. So now here we have 3 data points. So we can fit a polynomial of degree 2. So p2x is f of n minus 1 plus u into delta of f of n minus 1 plus u into u minus y factorial 2 delta 2 f of n minus 1, where u is now x minus the starting point is xn minus 1. So xn minus 1 by h. Fine. So then substitute this value here. So yn plus 1 is equals to y of n minus 1 plus, because dx will be what? From here dx will be h du. So h du. And now this is the polynomial f of x, and limit is now from u equal to 0 to 2. This is 2. Fine. So 0 to 2. So now integrate and then substitute the limit 0 to 2. After simplification and putting all the values of differences, what we will get? We will get this. We will get this final formula. So this is called as the implicit method or the corrector method. Now here this is called implicit, not explicit. Why? Because in the left hand side we are having yn plus 1. However in the right hand side we are again having f of n plus 1. तो दोनों में आप देख सकते हैं इधर भी n plus 1 है, इधर भी n plus 1 है. यानी ये चीज हमें नोन, कंप्लीट नोन नहीं होगी, क्योंकि ये चीज हमें नहीं पता होगी f of n plus 1. फाइन. सो इसी पॉइंट पे फंक्शन की वैल्यू पहले पता होगी तभी हम निकाल पाएंगे y of n plus 1. दैट इज वाई दिस इज इम्प्लिसिट मेथड. फाइन. तो इसके लिए हम क्या करेंगे? फर्स्ट वी विल प्रिडिक्ट द वैल्यू. तो हम पहले प्रिडिक्ट करेंगे वैल्यू इस फॉर्मूले से. दिस इज द प्रिडिक्शन फॉर्मूला. सो हमें yn plus 1 पता चलेगा यहाँ से प्रिडिक्शन से. वंस वी आर हैविंग xn plus 1, yn plus 1, देन वी विल यूज दिस फॉर्मूला, these values to predict f of n plus 1. तब हम f of n plus 1 की वैल्यू निकालेंगे एंड देन वो वैल्यू हम यहाँ पुट करेंगे. फर्दर एंड फर्दर वी विल करेक्ट दिस वैल्यूज फर्दर एंड फर्दर. सो दिस इज द प्रोसीजर एंड these two formulae is known as Milli predictor corrector method. Fine. So we are having two formulae. One is for the prediction, this is the prediction, and this formula is for the correction. Fine. So now in the next video we will take one example. Fine. So thank you.